evening. Well, I'm very much appreciated to stay here because I discovered robotics, in fact, here in this university. And for me, it's a privilege to stay here on time to time to show you some activities dealing with robotics now in Castellón. But I was here in this department a long time ago. So, well, the first thing that I would like to say is that, this is something very different of the things that you are normally discussing here in ValgrAI, okay? So I would like to remember the SACE project in the very so long time ago, in the 60s, 70s years during the last century. Remember that in this stage, one of the first intelligent robotics was promoted, and STRIPS planner and A-star algorithm were born there in this very preliminary stage on robotics. So it's only for remember that robotics is part of artificial intelligence, and artificial intelligence is part of robotics all the time. So, but let's say what happened with the extreme environments, that I think that this is require an special clarification. We are talking about systems that are underwater robotics for intervention, or in landing intervention robotics, but focus on a very specific environment, that is the extreme environments. What does it mean that? Extreme environments in the sense that without the use of robots, these kind of environments are extremely risky for human being. So this is the key. And in fact, we are facing two specific environments, underwater and also those environments that has a lot of radiation. For example, in CERN, activities in the nuclear research activities that normally are developed in CERN, we are obligated to use this kind of robots in order to prevent risk for the human being. So, in the things that I would like to show you, there are 3 PhD students that are working in a very associated area to this kind of activities. One of them is Alejandro, working in new mechatronics progresses. Andrea, that is able to implement a robot fish that now is ending her thesis. And Salvador, that is working in a very excellent manner, improving all kinds of functionalities for the new autonomous underwater vehicles for intervention. This is our special infrastructure in Castellón. You can see here, the Research Center on Robotics and underwater activities, technologies. And this is the water tank that we have. This kind of water tank has 5 meters depth. And here in the lower corner, on the right, you can see this special transparent wall that is fantastic for enabling all kinds of monitoring activities and testing everything. So, and this is a picture only 2 weeks ago. So, and what kind of activities we are developing here? For example, we are very focused on human-robot interaction. This is an area that is extremely important for this kind of robots for intervention in extreme environments. And also, we are working a lot with this kind of underwater intervention system. And normally, all the complexities that we need for navigation with an underwater vehicle and for manipulation with a robot arm like here are need to be controlled together, everything. For example, here normally we have 10, 12 degrees of freedom, and you need to control everything in order to succeed with any situation that you want to solve. And also we are working in real environments, because normally what happens is that this is extremely complex, this kind of system, and we need to start with the simulation, obviously, of all our new algorithms and integration of everything, of software and hardware. And if everything is okay there, we move to the water tank, and after that, we require the sea trials for the end of our test of every system here. You can see the surface vehicle in which now we are working with a special large system, launch and recovery system of the underwater vehicle. And this is basically our activities, and I would like to reflect very suddenly, very synthetically, what kind of collaborations and international teaching and ongoing research we have ongoing today. Well, a few years ago, we were cooperating with the Spanish Navy, and we were working in a problem that was like the title here, SIMBAD, Integrated Aquatic Threat Monitoring and Search System for Defense. So for that, we require a lot of mechatronics integration, communications, and all kind of software and hardware integration. And you can see here the coordination of the surface autonomous vehicle with the different buoys that are robotized, and with the underwater vehicle that is here. And, well, at the end, with some deep learning techniques for the vision part that is inside of this underwater vehicle, we were able to solve the kind of problems that were looking for the Spanish Navy for these specific activities. So one of the main cooperation agreements that we have ongoing today is with CERN, the European Organization for Nuclear Research, that I commented before. The last signed cooperation was here in 2023, and was signed by 10 years, so 2033 will be the end, but we hope to continue cooperating. In fact, for example, this guy is Carlos Veiga, was a previous student from our university, and now is the leader of the interventions that require periodically to be carried out in these installations in CERN, for example. And he's ending his PhD thesis, and I suppose that at the end of this year, also in our university campus, will be defended his thesis. So another kind of collaboration that for us is very fruitful sorry, is with the people coming from oceanographic media. For example, people working in the Spanish Research Council in a special aquaculture institute that we have very close in Castellón of our campus. And in fact, this was a usual operation trying to update some sensors that these people require all the time, putting the seafloor, in this case, in the Columbretes Islands. So, well, these kind of things could be, we are trying to cooperate in order to help with some underwater robots for doing specific operations. Another dimension that I would like to comment is international teaching, because I think that teaching in general, I think that is an obligation for teachers. Sorry. And we need to guarantee the transmission of our knowledge all the time with the best manner to this kind of students that are coming, for example, from an Erasmus Mundus master that we are active today. And this kind of master is focused on marine robotics, intelligent marine robotics, and with 2 years normally that are spending the students. The first year in Toulon, that is the coordinator of this master, and the consortium is formed by Norway, Portugal, and Spain in Castellón. And when the students are selecting the study track for coming in the second year to Castellón, for example, our contest there is underwater intervention systems. But, well, this requires a lot of things, perception, action, control, manipulation, and so on. So these are some pictures about these activities dealing with this kind of teaching issue. And for example, we were organizers in 2023 in Castellón of the annual meeting of this master in combination with an international workshop that is Martech. And so here some companies, students, researchers, everybody is interacting, and we think that this kind of contests are very, very much interesting for teaching. And at the end, the main focus, the target of my discussion here, that is what's happened with the intervention systems today. How is now developed this kind of activities in the real world? The state of the art of the intervention today is carried out by this kind of very heavy and very expensive systems. So normally you have a special ship with dynamic positioning with tethers and umbilicals in order to deploy the underwater vehicles. You need inside of this special ship a lot of cranes, a lot of resources. For example, the cockpit from where the ROV pilot, remotely operated vehicle, is all the time controlled by a human being here, the robot pilot. And there is a lot of complexities, and we want to, this is normally our starting point in order to have the motivation to improve the situation. No? We want to reduce a lot the complexities, and we want to reduce the expenses and everything. So when we started to work with underwater robots, we were in 2009. This was our first project that was funded by Spanish Ministry. And in parallel, 1 year later, we started another European project, both coordinated by my team. And at the end, we were able to deliver what? To deliver this kind of very fantastic prototype that was able to go and recover, for example, a target that could be that, a black box mock-up of an airplane that previously crashed in the ocean. So the question that I would like to tell here is, and what happened with this prototype? Where is now? Because this ending in 2013, so we are in 2026, and it's not in the market, this prototype. We don't have nothing similar to this prototype in the market. This is what the crude reality today with robotics. So, but the reasons are a bit long to explain here. And well, and now what I'm doing now? So very recently we finished in 2025 one of the projects that is changing our lives as researchers in Castellón, that is inside of the Thinking Azul program with Next Generation European funding. And here our project Jellyfish was something fantastic. We can summarize here a bit in this video the kind of activities that we were developing here. Because why, when I put my title Underwater System for Extreme Environments, one thing is that you have an extreme situation that is punctual, that is singular. Another different thing is that you are continuously working in extreme environments because you have, you need to face IMR operations, inspection, maintenance, and repair operations all the time, because you have some artificial structures in the sea floor, and you need to go there, not 1 day per year, not. Every hour, every day, every year. So this is changing everything. So in which manner we can help from the robotics and artificial intelligence point of view this situation for helping in IMR operations. This is the challenge now. And you can see here that we need to identify some breaks in the nets, in the fish farms, or and if you identify well and geolocalize this kind of breaks, you need to go after that and repair and so on. And you can, for example, implement a robotic fish, trying to assess some, for gathering any kind of information inside of a cage in a fish farm, for example. And this could be fantastic in order to transport some sensors that are taking measures about temperature, pH, oxygen, I don't know, dioxide of carbon, whatever. And everything could be here in this kind of fish robot, and this is very helpful in order to prevent a lot of critical situations inside of a cage in a fish farm. And also I would like to remark what happened with the communications. This is one of the weakness points all the time in our underwater systems. In underwater, there is not a wireless communication link that be able to run in a suitable manner. So, for example, we are experimenting with visual light communication now in the most advanced system that is that you can find in Hydromea company in Switzerland, and they saw that, well, this is fantastic, you can use in 50 meters distance in underwater, and that's not true. When you are trying in real situation, that is reduced maybe 6, 7 meters, no more. So we have a crude problem with communication in underwater. So I would like to remark also that before or during our activities in aquaculture, in precision aquaculture, we were solving other problems like cooperative transportation and cooperative assembly. That is something very, very new for the robotics community. In fact, never before was demonstrating these two operations in realistic conditions inside of an underwater tank with real robot systems. So I think that this is something very promising. And, well, we return again, we're coming back to the aquaculture scenarios. Why? Because before to end the Thinking Azul program in 2025, we got 2 new projects. One of them, Artemisa, and another one that is Tandem. And both are perfectly focused on aquaculture, on the aquaculture context, because we are focused on the IMR operations in this very complex problem. So this is the envisioned concept that you can imagine. You have 4 years in order to advance in this direction. You need a very good experimental roadmap in order to guarantee some progress for that. But obviously, it's very difficult because you can imagine what happened here. This is tremendous size for any cage and a lot of hostile environment parameters you can see here. No? The turbidity of the water, the extra pressure. Remember that each 10 meters depth, you are surprised with 1 atmosphere more of pressure, and the currents, the biomass that you have there. So you have an extremely difficult environment here. So Tandem is working on the same direction, but very focused on the coordination of the surface and underwater vehicles. Because I have only 1 minute. So this is the reality today. How are solving the problems today in these IMR operations in the fish farm? Here, you can see. You have the diver, and how is, if you are able to detect that, now, for example, the TRL, the maturity of the technology for the robot systems able to do that, this kind of identification and your referenced breaks in the nets, is very high, okay? It's very high. We are we have solutions very suitable for that. What is now an authentic challenge is, and well, you detect it and repair. This is the problem today. This is not. The TRL is I don't know any prototype in a university solving this kind of problem. Because when you see the diver solving the problem. You can imagine the diver is extracting a cable tie and is putting in real time exactly when he's aware about a break. So if you are trying to do the same or something similar with a robot, you have a real challenge there. But well, we are trying. And in fact, the PhD thesis of Salvador Lopez is working in this direction, and now it's impossible to do that, but we are able to put a patch, like here. Here, okay, this is how you say, and a similar operation is reducing a lot the complexity, because you don't have the dexterity in the manipulation that you require, and this is today impossible. And that's all. I think that, well, we were working a lot with this robot fish, and this is the challenge underway, in fact. If we succeed with a good tandem here, with the surface and the underwater vehicles well coordinated, and we are able to put the dual arm system here, and we are able to inject the autonomous behavior able to solve the problem of the cable tie in order to repair, will be fantastic. And that's all. Thank you very much.
Thank you, Pedro. Questions?
Oh, thanks. That was a very nice presentation.
Thank you.
In all these cases, the robots are completely autonomous, or are not? Okay.
Well, the intention for the long-term objective could be more or less that. But today it's impossible the full autonomy, because we have extremely serious problems, you know, like, for example, communication. But what is true is that what we are injecting here is some autonomous behaviors for be able to succeed in very, very specific tasks. For example, if you are able to identify the break in the net, and you are able to approach there, because you are able to recover the georeference that you are registering when you pass firstly to this area, you can repair in an autonomous manner, because you are in front of the break, and you are able to carry out in an autonomous manner the algorithm that you have, that is guided by vision, but not only vision. Sorry, I avoid a lot of complexities here. For example, you be aware about what happened with the net. The net is moving all the time, and it's a deformable object. So this is extremely difficult. If you don't have, for example, a kind of tactile sensors, a kind of force sensors there, combined with vision, in order to put the patch or whatever, you are unable to do nothing. So this is why it's so difficult, this problem. Indeed, inside of a water tank, because a water tank is a thing, and another very different is in the open sea, that is extremely difficult. But indeed, in a water tank, we are very, very far today of the good solution for repair the net. But we are progressing. This is the only reality today.
Okay. Thank you, Pedro.
Thank you.